All right, these are the answers to our parametric worksheet. So for this one, we're trying to build a table and see what this looks like. And all we're really doing is just putting these values in for t in both of these and see what x and y equals. So if we put -2 in, we're going to get 4 plus 1, we're going to get square root of 5 for x. And if I put that in, I get 2 minus -2, which is 4. Square root of 5 is a little over 2. So a little over 2, 1, 2, 3, 4, we're right there to start with. That's at t equal -2. If I put -1 in, I'm going to get square root of 2, and I'm going to get 3. So square root of 2 is not, square root of 5 is a little over 2. Square root of 2 is between 1 and 2. So somewhere in here, and then 3, so right about there. Okay, if I put 0 in, I'm going to get square root of 1, which is 1. I'm going to get 2, so 1, 2, right about there. Okay, so we're moving in this direction, and I want to indicate that, so I'm going to put an arrow here to let people know that we started up here and we're moving in this way. Okay, if we put 1 in, we're going to get square root of 2 again, but we're going to get 1 for that. So now we've come back to the x value, but we're down here. If I put 2 in, I'm going to get square root of 5 and 0. So now I'm back to this value, but at 0. So now we're going in this direction. Again, I'm going to put an arrow in to let people know that's how we're moving. If I put 3 in, I get square root of 10 and -1. Square root of 10 is a little bit bigger than 3. So now we're going this way. Put 4 in, I'm going to get square root of 17 and -2. That's a little bit bigger than 4. -2. So now we're going like that. If I put 5 in, I get square root of 26. And if I put 5 in there, I get -3. So a little bit more than 5, -3. You can see that this is starting to kind of be almost linear here, right? This is square root of 37, -4, which is right about 1, 2, 3, 4, right about there. Again, I want to put arrows in to let people know what way we went. So we traveled this way and then moved in that direction. Right? But that's what we get. Kind of a parabola shape, but not really. Almost linear here at the end. All right, so for this one, same idea. I want to put these values in and see what we get. So for this, we have 4 plus 2 cosine t. If I put 0 in, the cosine of 0 is 1, so 4 plus 2 will give me 6. If I put 0 in here, the sine of 0 is 0, so I'll get -1 plus 0, which is -1. So 1, 2, 3, 4, 5, 6, -1. This is where we're starting. All right. Now, as far as these pi over 4 values go, they're kind of obnoxious. They end up being decimals. We're going to skip over those for right now and just do the pi over 2 and the pi and see if we get a decent look from there. So if I put pi over 2 and the cosine of that is 0, so 4 plus 0 will give me 4. If I put that in here, the sine of that is 1, so I'll get -1 plus 4, which is 3. So 4, 1, 2, 3, 4, 1, 2, 3, right there is what we'll get. Okay. If I put pi into cosine, I'm going to get -1, so this will be 4 plus -2, which is 2. If I put pi in there, I'll get 0, so I'll go back to -1. So I'll be at 2, -1, right about there. Okay. If I put 3 pi over 2 in, cosine of 3 pi over 2 is 0, so I'm going to go back to 4. The sine of 3 pi over 2 is -1, so I'm going to get -1 plus -4, which is -5. So I get 4, 1, 2, 3, 4, -5. And then we're back to here, which is the same values that we started with. So you can kind of see what we're dealing with. We're dealing with an ellipse, which moved in this direction here. All right. And again, we were able to do that without having to do those obnoxious other ones. All right, now we're asked to eliminate parameters, and the easiest way to eliminate parameters is find the one where it's easiest to get t by itself, which is this y right here. If I were to subtract 5 and divide by 4, that's what t equals. So I'm going to take that and put it in for t here. So x equals 1 over y minus 5 over 4 minus 2. While obnoxious looking, that is an equation that has no t in it, and that'll get the job done. Same thing here with number 4. If I were to add t and subtract x, I would get t equals 6 minus x. Let's put that in for t right there. So y equals the square root of 3 times 6 minus x minus 4. No need to go any further. You can if you want, but that is an equation with no t in it. Right. Same thing here. I think this will be the easiest one. If we subtract that 4 and then multiply everything by 2, then t equals that. Okay, I will in this case distribute it since we have to use it for the substitution. And then we'll put that in right there. So we'll get y equal to 2x minus 8 cubed. That's our equation. Okay. For cosines and sines, remember we're going to use the idea that cosine squared plus sine squared equals 1. So what we're going to do is divide by 3 on the top one, divide by 3 on the bottom one, and then cosine squared plus sine squared, so cosine squared plus sine squared equals 1. All right, and that'd be our equation. Same thing here. We're going to subtract 4 and then divide by 2. That's cosine t for this. We're going to add 1 and divide by 4. That's sine t for this one. And so x minus 4 over 2 squared plus y plus 1 over 4 squared equals 1. So these are just how you write ellipses in parametric mode. And then for this one, we're going to use a different form for this. So we're going to use secant squared minus tangent squared equals 1. We can develop that or remember that from our trig identities from a ways ago. And x over 4 is the secant. Y over 3 is the tangent. So x over 4 squared minus y over 3 squared equals 1. All right, and then that would be our equation to get rid of it. All right, number 9 wants us to find these times where we're equal to these. Now you could use either one of these equations. I don't think it necessarily matters. If I look at this, is probably the easier one to do. What time would I be at negative 5? Well, that would be at negative 4. Negative 4 minus 1 would give me negative 5. When would I be at negative 3? That would be at negative 2. Negative 2 minus 1 would give me negative 3. When would I be at negative 1? That would be at 0. Positive 1 at 2. And then 3 at 4. Now I might want to just check if I did half of this, I get 2. 2 plus 2. I'm sorry, I get negative 2. Negative 2 plus 2 is 0. Check over there. If I take half of 4, I get 2. 2 plus 2 gives me 4. All right, so that all checks out. So again, it doesn't matter which equation, they're going to match up. Just pick the one you think is easier to work with. Okay. This one gives us a parametric equation for x and y. It says, where's the particle at 4 seconds? So we're going to put 4 in for x's equation. 5 times 4 is 20. 20 minus 4 is 16. That's the x coordinate. And then we're going to put 4 into y's equation. Negative 3 times 4 is negative 12. Plus 6 is a negative 6. When is the particle at this position? Again, you can pick either one of these. It doesn't matter. We'll just go ahead and use the x one right here. So we want to know when 5t minus 4, the x position, when is that equal to negative 14? So if you add 4, you get 5t equal to negative 10, and this is at t equal to negative 2. Okay. Now, if you wanted to make sure, you could put that into the y one. Negative 3 times negative 2 is 6. 6 plus 6 gives you the 12. All right, it checks out. Then it says eliminate the parameter, and what are you looking at? So again, you're going to have to pick. It doesn't matter. Let's just go ahead and get the t by itself on the x one. So for that, we're going to add 4 and divide by 5. And so we get t equals x plus 4 divided by 5. And now we're going to put that into the y equation right there. Right, so we're going to get y equals negative 3 times x plus 4 over 5. Right. Now that looks really strange, and if you wanted to, you could distribute this out and start looking at it. But really, there is nothing being squared, and we could separate the negative 3/5 and distribute it, and we'd have something times x plus something else. This is going to fit into your mx plus b form. It's not going to be a pretty one, but it will work that way. What we're looking at is just a line, or if you want to be more geeky about it, a linear equation.